All right, so the first thing I want to do is explain that there was two versions of this test, and it didn't necessarily say test A and test B. Both of them said test A, but one of them had a dot right here after the 9. That was my way of calling it test B. So everybody thought they had the same test, but it was actually a different test, right? So if you happen to not have a dot, then that's version A. If you did have a dot, it's version B. I'm going to be going over version A, so I want to erase that dot. Okay, so if you see this up on your test with no dot right here, we're going to be going over that version of the test, version A. If you do happen to have a dot, it's version B. Follow along anyway. It's going to be very similar to it. Maybe I'll make a recording of that other version later. Anyway, on this first section, here's another thing, guys. It says, please show your work on space provided. If you don't show the correct work, you're not going to get credit for it. If you're showing me some work that we did not learn in class, and what do I mean by that? Photo math, that's not going to cut it either, right? Because there's some people that showed this like perfect work, but it was done in a different way than I taught you, which is totally fine if you're able to explain that to me. If you learned it that way somewhere else, it's fine. But if you just copied straight out of photo math without me knowing, then of course I cannot give you credit for that. Anyhow, number one. It says factor, and when we look at this, you always start with the first method of factoring that we learned, which is what? Anybody? Are we awake? Greatest common factor. Pull out the GCF. So if I put some parentheses down here, and I look at the 8, the 12, the 32, what's in common with those coefficients? What's in common? What could I pull out of there?
4.
A 4, yeah. 2 is good, but 4 is better. 4 is the greater value that I could pull out. And then with regards to A's and B's, I could pull out a B squared for sure. Are there A's in all of them? No. So I could pull out a B squared. So my GCF really is 4B squared. Is everybody comfortable with that? Everybody understands why it's B squared, why it's not just B? Like right here we have 4 B's, right here we have 2 B's, right here we have 5 B's. The maximum that we could pull out of all 3 of them is 2, right? You could pull 2 out of here, 2 out of there, 2 out of there. You can't pull out 4. You could pull out 4 out of here and 4 out of there, but you cannot pull out 4 out of there. So the GCF is 4B squared. Okay, so now it's like reverse distributive property. 4B squared times what is 8AB to the 4th? Now let's start with the numbers. What's 4? 4 times what gives us 8? 4 times 2 gives us 8. Okay, so I need an A, but I don't have an A, so I need to have an A right here. Does that make sense? So I need to put an A right in there. And then I have a B squared that I'm going to multiply by something to give me a B to the 4th. What will that be? B squared. Okay. And then how about 4 times what gets us 12? Positive 3. Okay. And then B squared, actually, notice that we need an A up here, so I need an A down here for sure. And then the B squared times what will give me a B squared? It's just 1, right? And it's pointless to put a 1 right here because it's still going to be 3a. 3a times 1 is still 3a. So I don't have to put anything right there. And for the third term right here, 4b, or 4 times what gets us a negative 32? 4 times negative 8 gives us a negative 32. And then b squared times how many b's will give me a total of 5, b to the 5th? B to the 3rd. Okay. B to the 3rd. And ladies and gentlemen, that is all that we could do on number 1. So the correct answer is E, none of the above, right? Let's jump to number 3. So we're going to be doing the odd ones on this video, and you guys could try the even ones on your own. So right here, number 3, again, we have a simple situation here because the A value is 1, which means we can use the shortcut. Right? When the A value is 1, it's just 1x squared. You could just set the x right there and the x right there. Why? Because x times x really is x squared. And then all you have to do is think what times what is the C value that if you combine together is the B value. And if you don't see it right off the bat, you might want to make a list. All right? How could you get 24? Well, 24, you could go 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. Those are all the possible ways of getting 24 besides changing the signs. So if I combine 1 plus 24, I'll get 25. Is this number 25? No, it's negative 11. If I add 2 and 12, what do I get? 14. Is this 14? No, it's negative 11. 3 and 8. If I add 3 and 8, what do I get? I get 11. And this is negative 11. So I have the right number. I just have the wrong sign, which means I have the right numbers, but I have the wrong signs. So let's change it to a negative 3 and a negative 8. Then that'll be the right combo. And you simply plug them in, put a negative 3 right there, a negative 8 right there, and you're done. It's the easiest type of question we could have on this test, I think. Jumping to number 5, doing the odd ones here. Again, you always start by pulling out the GCF. So put parentheses. What's in common with the coefficient 6 and 3? A 3. Okay. And then how about, is there r's in both terms? Yes. What's the maximum amount of r's I could pull out from both at the same time? Just one. Okay, so let's put one r out here. And what's the maximum amount of t's I could pull out? Just one t, right? So let's put 3rt, and that is our GCF, 3rt. So now it's kind of doing distributed property backwards. 3 times what gets us a 6? 2, okay? And then how about r times what gets us an r squared? An r, right? And how about t times what gets us a t? 1, right? You could put it times 1, but that would be pointless because 2r times 1 is still 2r, so I wouldn't even write it. You just leave it like that. Okay, so how about over here? 3 times what gets us a negative 3? Negative 1. And then r times what gets us an r? A 1, so you don't even have to mess with it. How about t times what gets us a t squared? T. So there it is. There's your answer. 3rt times 2r minus 1t. And the fact is, you don't need the 1 right there. You could just write it as 2r minus t. And that's exactly what this answer is down here, D. 3rt times 2r minus t. Again, we have the 1. You don't need the 1. So erase it. Jump into number 7. Factoring by grouping. I gave these as freebies, but I want to explain them anyway because we need to know factoring by grouping. And if you have 4 terms, this could have been done way easier, but I wanted to see the work factoring by grouping. If you didn't show me the work factoring by grouping, you didn't get credit. So you could have combined the middle terms and then factored thinking what times what is a C value that if you combine together is a new B value. But right here I wanted to see you show me factoring by grouping. And what's factoring by grouping? You separate it into 2 groups. You have b squared minus 2b, and then you have plus 3b minus 6. Now in the first group, what could we pull out? What's the GCF in the first group? B. So let's pull out that b. What would be left on the inside? A b minus 2. Now how about that second group? What could I pull out of that second group? What's in common with the 3b and a 6? A positive 3, right? And what would be left over on the inside? A b and a minus 2. Now that's a very good thing because I have a common binomial, b minus 2 in the first group and b minus 2 in the second group, which means if I put some exaggerated parentheses, I'll be able to pull out that common binomial of b minus 2. And what will I have left over? Well, I'm going to have this b left over, so let me write it down here. I'm going to have this positive 3 left over. Let me write it down here. And the reason why I exaggerate the parentheses is so you guys could visually see that the b minus 2 is missing right there and the b minus 2 is missing right there. So of course on your answer sheet, you're going to write it with the correct size parentheses, the b minus 2 times b plus 3. And that right there is the final factored form using factoring by grouping. Let's jump to number 9. Number 9, we have a quadratic trinomial, but the a value is not 1. So we had to use the multi-steps to be able to factor this. And we like using that magical shortcut. So let's start by doing step 1, multiplying a times c. A is 6, c is negative 3. So a times c, that really gives me a negative 18. Okay, that's my answer for step 1. Step 2, we need to make a list. make a list of what? Of the answer from step 1. We want the multiples of negative 18 that combine together to give us the b value, which is positive 7. Okay, so let's make a list of the multiples of negative 18. I could get negative 18 by multiplying negative 1 times 18, negative 2 times 9, negative 3 times 6, and that's about it. So which pair of numbers combines together to give us the b value, which is positive 7? The negative 2 and 9. If I add negative 2 plus 9, I will get a positive 7, and that's exactly what the b value is. So now let's move on to step 3 of this thing. Step 3 is where you just set up your answer format, but you put ax, but we know that the a value is what? Let me erase the a. What are we going to put as the a value right there? What's the a value? Let me repeat that. What's the a value? A 6 right here, right? So let's put a 6 right in here. Okay, so ax, this is the magical shortcut method. So then I take the answers from step 2 and plug them right in there, a negative 2 and a positive 9. So let me do that. Let me put the negative 2 right here, positive 9 right there. And the fourth magical step is to magically divide each of those binomials by whatever you can. Okay, magically divide each of those binomials by whatever you can. So the first parenthesis, I could divide each of those terms by what? By 2, which would give me what as a final binomial? A 3x minus 1. And the second binomial, I'm going to magically divide it by what? By 3. And what will I have left? A 2x plus 3. And this is my final answer. Now, you could have done it different ways, right? The first method of me showing you how to factor this quadratic trinomial when your a value is something else than 1, same thing, a times c, you get a number. Step 2, think of the multiples of that number that combine together to give you the b value. And then I would tell you to change the 3 terms to 4 terms by rewriting this b value as these 2 terms. So you'd really have a negative 2m plus 9m. And you'd have 4 terms, and then you could factor by grouping. That's totally acceptable. That's a great way of doing it. But this way is way faster. Okay, so I recommend sticking to this way, where you magically put a ax, and put this numbers right in there, and then you magically divide this by whatever you can, and divide this by whatever you can, giving you your final factored form answer. So those are the odd ones on the front side. Let's turn to the back side. So again, you need to show your work. And we're doing the odd ones here. So what should I try to do first when they ask us to factor? Pulling out the GCF is correct. So what is the GCF? What could I pull out of all 3 terms? What could I pull out of there? Think about the coefficients, 50, 60, and 18. What could I pull out of there? Come on, guys, wake up. We can pull out a 2. So let's pull out a 2. What will we have left on the inside? A 25x squared minus 30x plus 9. Now, could I do anything else? Some people left it like this, and you only got half credit, because you need to look at the inside of the parentheses and see if you could continue factoring. Now, on the inside of the parentheses, I put them in blue. These are perfect square terms, all right? So I have a perfect square term right here, and I have a perfect square term back here, which means that maybe I'll be able to factor it by taking the square roots and plugging in the appropriate signs. So what is the square root of 25x squared? 5x. So I'm going to put a 5x right there. And what is the square root of 9? 3. So I'm going to put a 3 right here. So I repeat that, 5x and 3. Okay, don't forget about the outside 2. It needs to come down as part of your answer. Okay, now what about the signs? Is this going to be positive? This one going to be negative? Is this going to be positive and positive, or both negatives? Positive, positive. So think about this. If I did have both positives and everything's positive, how the heck am I going to end up with a negative right here in the middle? It's not going to happen, right? So they both have to be negative. Why is that? Because a negative 3 times a negative 3 at the very end will give you the positive 9. And when you have negatives here, when you do the middle terms, it will give you that negative 30. Well, at least we hope. So let's put a negative there and a negative there. There's no way that one could be negative and one could be positive, because that would make the middle terms cancel out. And obviously, right here, we do have a middle term. Okay. So anyway, if you were to check, 5x times 5x is 25x squared. 5x times negative 3 is negative 15x. Negative 3 times 5x is negative 15x. If you combine both of those negative 15s, you'll get that negative 30 in the middle. Anyway, this is the correct factored form. This is the answer. Or you could also write it as a binomial squared. You could have written it like this on your answer sheet. 5x minus 3 squared. Let's jump to number 13. Could you pull out a GCF right there? No. There aren't x's in every single term. There aren't 5's in every single term. There aren't 2's in every single term. So you can't pull out a GCF from all of them. And I notice that I have 1, 2, 3, 4 terms. So what method would be great when you have 4 terms? Factoring by grouping, right? So let's split it into 2 groups. We have 20x squared minus 15x minus 6xy, or 16xy plus 12y. Notice I left space between them. So in my first group, what could I pull out? A 5 and an x. What would be left, bless you, on the inside of the first group? A 4x minus 3, right? When you say 5x times 4x, that'll give you 20x squared. 5x times what gets you a 15x? A 3. And of course, minus. And in the other one, what could I pull out of the other one? A 4 and a y, but the better option would be to pull out a negative 4y. Okay, so see, if I just put a 4 and a y, when I say 4y times what gets us a negative 16xy, that'll be a negative 4x, and we want a positive 4x. So that's why it's better to simply pull out that negative right from the start, so you could get that common binomial here and here. Okay, so we pull out a negative 4y. On the inside, we'll end up with a positive 4x. And then negative 4y times what gets us a positive 12y. That'll be a negative 3. And as you could see, it really is the same exact binomial in blue right there, 4x minus 3. So what I'm going to do now is do some exaggerated parentheses. I'm going to zoom out a little, and I'm going to pull out that common binomial of 4x minus 3. 4x minus 3 gets pulled out. The 5x comes down right there. The negative 4y comes down right there. And that's it. That's your answer. But let's write it with the correct size parentheses. We have a 4x minus 3, and we have a 5x minus 4. 4y. Thank you. Forgot the y. And that is it for number 13. Let's jump to number 15. So right here, we notice that the a value is not 1. B value is 10, C value is negative 3. So I need to use that multi-step method, but I could go with that magical shortcut way. So step 1 would be to multiply a times c. And when I go 8 times negative 3, I'll get a negative 24. Then after I get that answer, I make a list of the multiples of negative 24, like negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. And that's all the possible ways of getting negative 24 besides changing the signs. Anyway, which pair of numbers combines together to give us the middle value positive 10? Negative 2 and 12. If you add negative 2 plus 12, it will give you a positive 10. So that's the correct pair of numbers that we need for step 2. Now step 3 is to set up your factored form answer format, where we plug in an AX on each of these. However, the A value, we're going to actually write it in. What's the A value here? 8. So let's put an 8 right in there. 8x. And what belongs right here in these blank spots? What belongs in here? Yep, the negative 2 and the 12. The two numbers from step 2 go right in here. So let's plug in that negative 2 and the positive 12 right in there. And now the fourth magical step is to simply divide both binomials or each binomial by whatever you can. So on the first one, the 8 and the 2, that's divisible by 2. So we're going to magically divide them by 2. That'll give us a 4x minus 1. The second one, we're going to magically divide the 8 and the 12 by 4. So when we divide both of those by 4, that'll give us a 2x plus 3. Ladies and gentlemen, that is your answer, 4x minus 1 times 2x plus 3. If you wanted to double check it, all you have to do is distribute, and it will give you the above beginning quadratic trinomial. Let's take a look at number 17 here. We're finally to the equation parts, all right? Equation parts. So right here, we actually do need an answer. We need two values that are answers. So x equals something and something else. We want two values. All right, so let's first start by recognizing that this equation is not set equal to 0, and it would be easier if it were set equal to 0. So let's subtract 7x. That way, we could apply the zero product property. So what we have here is the x squared minus 7x plus 2 equals 0. That's your quadratic trinomial equation. It is set equal to 0. So now let's factor it so we could split it so we could solve it. Okay, so the first step, if you have an a value that's not 1, is to multiply a times c. So that's 6 times 2, that is 12. Step 2 is to think of the multiples of 12 that combine together to give you the middle value, which is negative 7. So we have 1 times 12, we have 2 times 6, we have 3 times 4. So which pair of numbers combines together to give us a middle value, negative 7? 3 and 4. 3 and 4 gives us positive 7 if I add them together, and we want a negative 7. So let's change the signs. We have the right numbers, we have the wrong signs. So let's make it a negative 3 times a negative 4. Okay? So this is the correct pair of numbers that we want for step 2. All right, so now I am going to move on to step 3, which is setting up my factored format, but it's going to be wrong so far because I'm going to put an AX on both of those. And we know that the a value is 6. So let's replace the a with the 6. So let's put a 6 right there. And we're going to take the pair of numbers from step 2 and just plug them into these empty spots. We're going to put a minus 3 and a minus 4 right in there. And then step 4, the magical step where you magically divide that top first binomial by whatever you can. 6 and 3, you could divide both of those by 3, so you will get 2x minus 1. And the other one, the 6 and the 4, you could divide both of those by 2, and you'll get a 3x minus 2. Now let's not forget that it still is an equation. There's an equal sign that's set equal to 0, so I need to bring that down. I need to set that equal to 0. This is one of the longest problems that we have here. And now that we have a binomial times a binomial and it equals 0, I could simply separate them and set them each equal to 0. So I'm going to separate it. 2x minus 1 equals 0 and 3x minus 2 equals 0. So on the first equation, I need to get rid of that minus 1. I'm going to go plus 1, plus 1. I'm going to have a new equation that reads 2x equals 1. If I divide both of those by 2, I'm going to end up with x equals 1/2. And that is one answer. On the other one, I'm going to go plus 2, plus 2. You're going to end up with 3x equals 2. Final step would be divide by 3. So you end up with x equals 2/3. And that's your other answer. So those are your two answers, two fractions for number 17. That's as hard as it gets. These are equations, and you need the actual answers. Some people left it in factored form. They left the 2x minus 1 times 3x minus 2. That's great. You factored it correctly, but I can't give you full credit because you need to be able to set them each equal to 0 and solve. Let's move on to number 19, the last one we're doing on this video. It says solve. You want to get x by itself. So it would not be a good idea. I mean, you could write this twice, distribute, get a quadratic trinomial, set it equal to 0, factor using the multi-step method. But the easier thing to do is think, I want to get x by itself. I need to get rid of everything and get x all by itself. Because there's only one x, there's no other x out here, there's no other x out here. Because there's only one x, I am actually able to eliminate things by doing the opposite. So in other words, if I want to get rid of this square, I could get rid of it by doing the opposite. And the opposite of a square is a square root. So whatever I do to one side, I must do to the other. And the only thing you have to remember is that when you apply a square root in an equation, you have to put a plus or minus right in front of your answer. Okay, so we know that the square root and the square eliminate, so I am just going to have the x minus 6 left over. Okay, and again, put a plus or minus right in front of the answer when you apply the square to 16. And the square to 16 is 4. So you really have a plus or minus 4. You have x minus 6, and you don't want the minus 6, so let's get rid of that minus 6 by adding 6. And what you do to one side, do to the other. I'm not going to actually do it yet. I'm just going to rewrite it. So what do I have left? I have my equal sign right here. I have my x right here. And I have the plus 6, positive 6. I don't even need a plus in front of the 6. But I do have the plus or minus 4. So what does this mean? Positive 6 plus or minus 4. It means that I have both situations. I have the positive 6 plus 4, and I have the positive 6 minus 4. So I actually get two answers. 6 plus 4 is 10. That's one answer. 6 minus 4 is 2. That's another answer. You have to have both answers to get full credit. So those are all the odd ones. I want to give you the rest of the period to do the even ones. And if you need help, there will be a video uploaded with the even questions later on Edmodo and on my YouTube channel.